And welcome to Math Light. And let me give a little shout out to Mrs. Cardamus and her class. All right, hope you enjoy the video. All right, let's talk about geometry. So we're talking about points, lines, and planes today. And first off, just general definition, what is geometry? When you think about geography, those kinds of things, you should think about the earth. So geo, and then the metry is measure. So geometry means earth measure. And what is it? It's a study of points, lines, planes, and the figures or shapes that they form. All right, so if we start with points, lines, and planes, we can make all kinds of different figures, and that's the concept of geometry. All right, so let's get rolling here. Points and lines and planes, these are the building blocks. It's what we take to build everything else. Now, geometry is it's a technical discipline in that we want to make sure that we have an airtight case. And to have an airtight case, fact must lead to fact, must lead to fact, must lead to fact. However, you have to start somewhere, right? There's got to be a beginning. That's important. And so with the beginning then, we're going to have undefined terms. Just things that we assume to be true. And we have to have them because we have to have something to build with. You know, how can you define a point if you have nothing in your arsenal yet? Okay, so that's the idea. So we're going to call these undefined terms, and we're going to describe them, but technically they're undefined. They're the assumptions, the things that we assume to be able to build our geometry. All right, so number two, what is a point? A point has no dimension. Has no dimensions. There's no length, there's no width, there's no height. Now you might think there is because, you know, normally when we draw a point, here I'll draw a point there, okay, that looks like there's length or width. But technically, there's none. There is none. When you start thinking about numbers, you know, you can always go between. All right, so anyhow, a point has no dimensions, no length, no width, no height. How do you represent them? All right, well, they are represented by a dot and are named using a capital letter. Now, geometry is a discipline that is a technicality, so we have to be technical in what we do. All right, so if I had point B, if I were to say that in words, I would write point B. All right, so capital letters for your points, capital letters for your points, capital letters for your points. All right, so point, no dimensions, and no length, width, or height in that point. Okay, number three. Number three, what about a line? What about a line? All right, so how many dimensions would a line have? And I hope you're thinking one. All right, I hope you're thinking one dimension in our line. So our line has one dimension, length, and is a set of continuous points that extend. How far does a line extend? All right, well, please notice, and students miss this, notice the end of the line has arrows. Okay, those arrows indicate that the line continues on forever and ever. A little bit of Jersey accent in there. Okay, the line goes on forever. All right, and we'll use the word indefinitely. The line extends indefinitely in opposite directions. It goes on forever and ever. All right, so a line has one dimension, length, and don't miss the fact that it's a continuous set of points here. Before I go to this next thing, let me just get you to understand. So yeah, I've shown you point X right there, but there's another point right next to it, another one next to it, another one next to it, and one next to that, one next to that, one next to that, another one, another one, another one, another one, another one, here's one, here's one, here's one, here's one, another point, another point, another point, another point. Oh, we hit finally point P, and another one, another one, another one, another one. You get the idea. I could go on forever, right? These continuous points, one right next to the other, forms the line. All right, A. How many points does it take to determine a line? This is something you should have learned somewhere along your elementary learning. And so hopefully you think two, right? Since any 2 points determine a line, then the line notation is any 2 points located on the line with the line symbol over top. Any 2 points on the line with the line symbol over top. Okay, so if we go back to the line that I have here illustrated, and we go back to this line, then how can we name this line? Now we can name it a number of different ways. Okay, I need 2 points on the line. So I hope you agree point A and point X are on the line. And notice I use capital A, capital X. Now, we're not done yet. If we want to say a line, we also have to use the line symbol. And that is the line over top with the arrows both ways. You got to have the arrows. All right, it's going to be something else. If you don't, we'll talk about that in a minute. Okay, line AX. How else could I have named this line? I could have named this line XP. I could have named it line XP. Hey, I could have also named it what? Line AP. Line AP. And as a matter of fact, there are 3 other ways to name this exact same line. It's all the same name. You know, it's all the same name. Theodore and Theo and maybe Ted would be all the same. It's that idea. Okay, but notice each time we're only using 2 points. Only 2 points that are on the line with the line symbol over top. So again, you can go backwards XA, right? You can go backwards PX. Yeah, go shopping there. And you can go backwards PA. Oh, now we're back in pre-algebra. All right. So that's all the same line. 6 different ways we name the same line because that line happened to show 3 points. If it showed more, we could name it a whole lot more ways. Okay, so I want you to look at something here. Line TP, does that line even exist? Is there a line TP? Where is that line? Well, yes, there is. Remember, any 2 points determine a line. Now, the line's not illustrated right now, but take a straight edge. I don't have one. I have to do it freehand, but take a straight edge and draw a line through those 2 points. And wouldn't that be the line TP? Of course it would. Again, notice I put arrowheads on the ends of both ends of that line. All right, so a line, what is it? It's 1 dimension. How do you name it? Any 2 points on the line with the line segment symbol over top. Okay, so we have a point, we have a line. Now let's talk about a plane. What is a plane? A plane is a flat, how many dimensional? All right, 2-dimensional surface. Right? A plane is a surface. Think of it as flat, right? So we use the word flat. Plane is a flat 2-dimensional surface. It has length, it has width, and it extends indefinitely in 4 directions. Extends indefinitely. Now, normally you don't see these arrows right here. I put them on there just to try to illustrate the fact that this plane goes on forever. Now, here's the point. If I were to draw the plane going on wider, you wouldn't see it. And so we always put a boundary, and we usually use a parallelogram to represent a plane. And again, those arrows usually are not there, right? But the plane goes on forever in this direction, forever in that direction, forever in that direction, and forever in that direction, in all 4 directions. Okay. So let's talk about our plane here. And so to name a plane, you must give how many points? And this is important. This is a key here. You must give 3 points in the plane. Now look the big knot that do not lie along the same line in the plane. Now this is really key, and I'll show you why in a moment. But we're ready to name this plane. It's pretty easy. So we call it plane. And then the 3 points that are not along the same line that are inside. Now there are only 3, an R and T and S. Now, those are my initials. You might say, why didn't you go RST? Well, because they're not my initials. And by the way, be the same plane. Right? Plane TRS is the same plane. Plane TSR, same plane. The order of the points does not matter. Now, it was important, though, that they were not along the same line, and I'll mention that one more time in a minute. Also, sometimes planes will have just a letter without a point designation, and that's a shorthand to naming the plane, so we can call this plane M. Now, here's the key to everything about the 3 points not being on the same line. If I had a point here A and a point here B and a point here C, if I say plane ABC, I have no clue what plane you're talking about. Now, we're in a little bit of trouble because I have to draw. And I'm telling you, I do not draw well, all right? But let's suppose that that's the plane you're talking about. Well, I don't know it's that plane because there's another plane that those points could be in that goes right there. And not only that, there could be another plane. Oh, now I'm in trouble. Now I'm getting all out of shape there. That line is in. Matter of fact, there's an infinite number of planes that line is in. And therefore, naming the 3 points doesn't tell us exactly what plane we're talking about. So it's got to be 3 points that are not along the same line to name a plane. All right. What else? All right, well, how about points that lie on the same line? We have a name for that. What do we call points that lie on the same line? So points that lie in the same line are called collinear points. Collinear. Notice the 2 L's. I always want to spell it with 1, but there are 2. So collinear are points along the same line. You got a pilot and a co-pilot. The co-pilot's in the cockpit, hopefully, with the pilot. They're there together. Collinear, points along the same line. Where those that lie in the same plane would be called what? So if we're going to call them collinear if they're on the same line, what are we going to call them if they're on in the same plane? And we're going to say coplanar, right? Coplanar points. So collinear along the same line, coplanar in the same plane. All right, let's see if we can answer a couple questions here. First question. Name line G in 2 other ways. Oh, well, notice another shorthand for naming. If you look, you'll find that little G, and it's right up here, right? So notice there's no point associated with it. It's simply there to give you another way to name the line. Now, we do know that it is talking about this line right here, right? So what are 2 other ways to name this line? Well, remember, you name a line with 2 points on the line. So I'm going to take 2 points on that line. Point R is on that line. Point B is on that line. And what am I forgetting? Yeah, the line symbol. All right, don't forget the line symbol. How else can you name that line? You thinking? Hey, don't be copying what I'm doing. Be thinking. All right, and I hope you're thinking BR. Right, we can switch the order. Okay, so we named line G in 2 different ways. Let's do another one. Name plane J in 2 other ways. All right, now we're talking about plane J. Well, plane J is the shorthand. The full way to remember is to use the word plane. And what else do you have to do? Again, I hope you're thinking 3 points that are not on the same line. Now, we can get a lot of answers for this. So there are various ways. We're only going to show you 2. So I always like to pick 2 points on the line, A and B, and a point not on the line, D. Okay, we name the plane, plane ABD. Again, I can change the order of the letters. It would be the same plane, and I would name it a different way. But to be a little interesting, how about if I use point C and point A, the 2 on the line, and then point D, the point off the line? Got it? All right, plane CAD. Yes, little computer-aided design there. C, give 3 collinear points. Give 3 collinear points. There's only one possibility here. All right, what are you thinking? 3 collinear points. Okay, and I hope you're thinking point A. Notice I put the point in the capital letter. Point B and point C are collinear points. 3 points located along the same line or on the same line. How about 3 non-collinear points? You got a lot to choose from. You got a lot to choose from. Okay. I'm just going to show you a couple. Whoops, I hate when I do that. Didn't grab my pen. So how about point R, right here? And then let's go with point B right here, right? So if I go point R, if I go point B, what other point can I use? I got a lot. So let me do it this way. If I use point R and I use point B, what else point could I use? I could use C or T or A or D. None of those points are on that line. So it's really my choice as to what point I want to use next. And so therefore I'll just pick one of them. Now let's use point A. Why not? Okay? 3 non-collinear points. Give 2 points on the line and a point off. Really, the only way to get this wrong is use points A, B, and C, because they're the only ones that are collinear. All right, E, give 4 coplanar points. I need 4 points in the same plane. Now, there are only 4 of them. The order does not really matter, right? What are you thinking? Hope you're thinking point A, point B, point C, and point D. Those are 4 points all in the same plane. 4 points all in the same plane. All right, how about F? How about 4 non-coplanar points? How about 4 non-coplanar points? Okay, to do this, to do non-coplanar points, you always want to pick 3 points in a plane and 1 point that's not. Okay, so hang with me on this one. I'm going to choose 3 points that are in the plane. So I'm going to go 1, 2. Now I don't want to do C. That would be wrong because they're all 3 on the same line. So I'm going to go 1, 2, 3. So I have point A, point B, point D. That establishes my plane. And now what other point would I pick? And I have 2 choices, point R or point T. Now we use T. It has been used, right? But I could say point R there. I've given now 4 non-coplanar points. So did you catch something? When you're going to give 4 non-coplanar points, 3 of them are in the plane, 1's out. That's the way it always works. Any 3 non-collinear points are always in a plane, and 1 would be out. 3 in, 1 out. Okay. What else? Geometry. A lot to it, but just some basic building blocks right now. All right. Terms that can be described using known words like point, line, and plane, right? We know them now, are called defined terms. Okay. So we needed our building blocks. We needed our assumptions. And so we assumed what a point was. We assumed what a line was. We assumed what a plane is. Now, from those, we can have defined terms. All right, and the first one is a line segment. Line segment. And what is a line segment? A line segment consists of 2 endpoints and all the points between the endpoints. So you can see in blue here, I have a line segment illustrated. And I've got an endpoint at point B. I've got an endpoint at point C. And notice the rest is blue because it's point B, point C, and this point, this one, this one, this one, this one, this one, that one, that one, that one, next one, next one, next one, this one, this one, this one, that, all the way to there, right? That is a line segment. So let me ask you this. How many points are there? Is the number of points of the line segment infinite or finite? Is there an infinite number of points or finite? Now you might think because there's 2 endpoints, it's finite, but it's not. Remember, a point has no width. It has no dimension. You can always get, this is weird, you can always get another point between any 2 points. Always. Can always get another point between any 2 points. So it's infinite. There's an infinite number of points. Okay, how do we say a line segment? Well, you got to use the 2 endpoints. We have to use point B and C. And then the segment symbol over top, all right, which is just a line without the arrows. So line segment BC. How would we say this same line segment another way? Well, we can reverse the order. That's the only way to do it. Line segment CB. Okay? So it's all the points from B all the way to C, including the endpoints, point B and point C, a line segment. All right, what else? Well, we can talk about array. Array. Array is a union, the putting together of an endpoint and all other points on the line, and this is key, in the same direction of the other point, or the same direction as the other point. So all the other points on the line in the same direction of the other point. What do you mean by that? All right, I'm going to show you in a minute here so you get the idea, but let's do number one here. Let's name the indicated ray. You can see it's in green. So the ray is in green. All right, pay attention here. We always start with the endpoint. The endpoint is a point, a specific point where, quote unquote, the ray, it really starts. All right, I know it's called an endpoint, but think about a line segment. So point T is where the ray starts. And what direction does the ray go in? It goes in the direction of what point? And most would say point S. Now we need the ray symbol. The ray symbol is a line with the arrow on the one end, exactly what a ray is. Has an end point and then it goes forever in a direction. So we have to understand that this ray starts at point T and goes forever in the S direction. So here's an important question. Number two, can you name the same ray another way? All right, why don't you pause and think about it, write an answer, and then unpause. Okay, are you back? So there's only one other way. The only other way to name this same ray, the exact ray, is again to have the endpoint first. It's point T, but you could have R, right? Because isn't the R direction the same direction as the S direction? They are the same. So it's the same ray, ray TR. Ray TS, ray TR, the same ray, but please understand that the endpoint has to be listed first. You have to list the endpoint first. You have to if you're going to get the notation of array correct. Right? And the idea is this. Okay, so if they said to you, ray TV, you should know exactly where that ray is. Where's that ray? Did I say ray TV? I did. Boy, I tell you sometimes. Ray SV, I'm sorry. Oh, brother. Ray SV. So you should know exactly where that is. The endpoint is S, right? Right there. And what direction does it go? In the V direction, right? And that would be ray SV. Okay, hope that makes sense to you. Number three, opposite rays. Okay, let's talk about opposite rays. Let me get this set up here. So opposite rays are two rays along the same line with a common endpoint. Two rays along the same line with a common endpoint. So name the pair of opposite rays if point K is the common endpoint. Okay, so this is what we should say. Ray KJ. Can you see that ray? I'll do it in blue. It starts here and it goes this way. What's the other opposite ray? Well, again, K, right? Ray KL. And I'll do that in yellow. That starts at point K and heads in that direction. Do you see the opposite rays? Now together, two opposite rays form what? They form the whole line. So if you union two opposite rays, you get the whole line. Okay? The name. All right, so opposite rays. Which ray is longer? Here, let me get rid of my illustrations here and go back to what we had originally. All right. Which ray is longer, ray KJ or ray KL? Which one's longer? All right. And I hope you say neither. They are the same length. Neither. They're the same length, which kind of is a misnomer, because guess what? They're both infinitely long. Therefore, they're both the same because they're both infinitely long. So which ray is longer? Neither. You say, but this one looks shorter. Well, I only drew it that short. Remember, it goes on forever. This one goes on forever. Got the point? All right, got the point. Beautiful. What else? All right, let's do a little bit of practice here and see if we can make some sense out of things. We've got a figure to the right. We want to name two pairs of opposite rays where point A is the end point. So I need two pairs. Okay, so two pairs here. So I'm going to do the first one. Let's call it ray AB. And its opposite ray would be ray what? Ray AL. Okay, there's one pair. What's the second pair? I'll go ray AC, right? A is the end point. And what's its pair? Ray what? And I could call it ray AD, or I could call it ray AE. It starts at A and goes in the D or the E direction. Okay? Two pairs of opposite rays where point A is the end point. Number two, give another name for line segment EA. Can you give another name for line segment EA? Okay, and I hope you said line segment AE, right? We can switch the order. What were they? That's point E, point A, and every point in between is line segment EA or line segment AE. All right, what else? Give another name for ray AD. Can you give me another name for ray AD? So it starts at A, has to be the end point, goes in the D direction or the E direction, right? Ray AE would be the other answer. Number four, are ray AB and ray BA the same ray? Are ray AB and ray BA the same ray? The answer is, whoops, sorry about that. The answer is no. No. My explanation would be they have different endpoints, therefore they cannot be the same ray. So one starts at A and goes in the B direction. The other starts at B and goes in the A direction. So let me ask you this, are they opposite rays? Right, they go in opposite directions? No, because they don't have a common endpoint. All right, got to know your definitions, right? Got to know your definitions. Name all the rays with point A as their endpoint. How many different rays are there? Okay, so I hope you look and see that there are 4 different rays, right? That's it. So again, we have ray AB, we have ray AC, we have ray AL, and once again, 2 ways to name the same ray, but it's ray AD or it's ray AE. It's the same ray. So how many different ones are there? There are 4 with A as their endpoint. 4 different rays with A as their endpoint. All right, number 7. Number 7. Hang in there, we're almost there. 2 or more geometric figures. And now we'll introduce the word intercept. Intercept when they have 1 or more points in common. So 2 or more geometric figures intercept or intersect. Maybe I should have used that word instead. Let's change that. Intersect, not intercept. I like that word better. 2 or more geometric figures intersect when they have 1 or more points in common. Okay, so we got a figure here, and notice we got a couple planes, and you can see the green plane and you can see the blue plane. So the blue plane is kind of slicing into the green plane. And we could call the green plane plane K, right? See the shorthand little K up there? And the blue plane would be plane R if we want to use the shorthand notations. All right, let's see if we can answer a couple questions. What is the intersection of plane K and plane R? What is the intersection of those 2 planes? First off, what is the shape? Is the intersection a point? Is the intersection a line? Is the intersection a plane? 2 planes intersect at exactly 1 line. And it's line XY. Whoops, that's not uppercase. line XY, right? And I could have called it line YX. That's where the planes intersect. Now remember, the planes go on forever in both directions, so that line does as well. So it's not a line segment because it's two planes, it's a line. Two planes intersect in a line. What's the intersection of plane K and line ZD? Okay, so we got the green plane and we got line ZD. All right, here's line ZD. So where do they intersect? And I hope you think right there at point X, right? At point X. So a plane and a line not in the plane intersect at exactly one point. Right, that line's not in the green plane, plane K. So it intersects plane K at one point. C. Name all the points shown in plane R. Name all the points shown in plane R. Okay, well, they've got to be in the plane. I hope you obviously think point D. Would you agree point Z? Okay, what else? Well, don't leave out point X and don't leave out point Y. Okay, so point Z, point D, point X, point Y. Point B is not, point E is not, point Q is outside both planes. Point Q is in neither plane, right? Okay, does that make sense? I hope so. Now, R is not a point, R is to name the plane, right? So don't say point R, there is no point R. R is naming the plane. There is no point there associated with it. Okay, last thought here. Let's look at our last thing. All right, so we're going to use the figure to the right to answer each question. Now notice we have a cube. We don't have a cube. We have a cube here. We have a physical structure. Okay. Name the intersection of plane CDE and plane AFE. Okay. So I'm going to use some color here to illustrate. Plane CDE. Okay. CDE is this back plane right there. And we have to intersect that with plane AFE. AFE. See how those 3 points fall in this plane? Okay, so if you want to think of it as a box, where does the back of the box intersect the bottom of the box? Back of the box intersecting the bottom of the box. Okay, so you have to be technical here. Okay, because it's a box and the box is in a plane and in another plane, so technically two planes intersect at a line. So line GE. Some would say the intersection is the line segment GE, but technically two planes intersect at what? At a line. Okay? So, but you got to look at that. Some teachers might say, no, we're just talking about the box itself, and therefore the box has a line segment GE. Whatever your teacher wants there, but technically two planes intersect at a line. All right, B, name a point that is coplanar to points F, E, and D. So points F, E, and D. Can you name a point that is in the same plane as point F, D, and E? And you have two choices, right? So hopefully you said point H, or you could have said point M. Those are the only 2 points that are in the plane of F, D, and E, right? It would have been this side of the box right here, right? Okay, and last question. Last thought. Name all points not coplanar, so not coplanar, or all points non-coplanar with points H, F, and E. So let's take a look at points H, F, and E. Name all the other points that are not in the same plane. Once you pause the video, give it a shot, and then turn it back on. All right, here we go. So it should have been point B in no particular order. Point C is not in the same plane. Point M is not in the same plane. Point G is not in the same plane. And finally, point A is not in the same plane. You can't say D, D's in the same plane. You can't say M, it's in the same plane, etc. Okay? All right, some terms there, review them, and they'll serve you well.